Chapter: Building AI Agents with LangFlow and the OpenAI Agents SDK. In the rapidly evolving world of artificial intelligence, building agents that can reason, act, and interact with external systems has become one of the most important engineering challenges. Two powerful approaches have emerged to simplify this process: LangFlow, a visual development environment built on top of LangChain, and the OpenAI Agents SDK, a programmatic framework for creating intelligent, tool-using agents. This chapter explores both approaches, helping you understand not only how they work, but when and why to use each one. Understanding AI agents. Before diving into tools, it's important to clarify what an AI agent actually is. An AI agent is a system that 1. Receives input, a question, instruction, or event. 2. Reasons about that input using a language model. 3. Takes actions using tools or APIs. 4. Returns a result, often after multiple steps. Modern agents go beyond simple chatbots. They can 1. Query databases. 2. Call APIs. 3. Use search engines. 4. Execute code. 5. Maintain memory across interactions. Building such systems from scratch can be complex. That's where LangFlow and the OpenAI Agents SDK come in. LangFlow. Visual development for AI agents. LangFlow is a visual interface designed to simplify the creation of AI pipelines and agents. Instead of writing large amounts of code, you construct workflows by connecting components in a graphical environment. Each component represents a building block. 1. Language models. 2. Prompt templates. 3. Memory modules. 4. Tools and integrations. Output handlers. By connecting these nodes, you create a flow that defines how your agent behaves. Key advantages of LangFlow. First, it dramatically lowers the barrier to entry. Developers and even non-engineers can prototype agents quickly without deep knowledge of back-end systems. Second, it provides strong visibility. You can see exactly how data flows through your system, making debugging far easier than in traditional code-based approaches. Third, it accelerates experimentation. You can swap models, change prompts, or insert tools without rewriting your entire application. Example workflow. A typical LangFlow agent might include 1. User input node. 2. Prompt template. 3. Language model. 4. Tool selection component. 5. Output formatter. This visual pipeline represents what would otherwise require dozens or hundreds of lines of code. Limitations of LangFlow. Despite its strengths, LangFlow has limitations. Complex logic, such as loops, conditional branching, or multi-agent coordination, can become difficult to manage visually. In such cases, developers often transition to code-based frameworks like LangGraph or custom implementations. OpenAI Agents SDK, Programmatic Agent Design. While LangFlow focuses on visual simplicity, the OpenAI Agents SDK takes a code-first approach. It provides a structured way to define agents, their tools, and their behavior in a programmatic environment. With this SDK, you explicitly define 1. The agent's instructions. 2. Available tools. 3. Decision-making process. 4. Execution flow. This approach offers greater control and flexibility, making it suitable for production-grade systems. Core concepts. The OpenAI Agents SDK revolves around a few key ideas. Agents. An agent is defined with a role and a set of capabilities. For example, you might create a research assistant agent that can browse the web and summarize information. Tools. Tools are functions the agent can call. These might include APIs, databases, or custom logic. Planning and execution. The agent decides when to call tools and how to combine their outputs to produce a final result. Example use case. Imagine building a travel assistant. With the OpenAI Agents SDK, you could 1. Define tools for flight search, hotel booking, and weather lookup. 2. Create an agent with instructions to plan trips. 3. Let the agent dynamically decide which tools to use. This results in a system that feels intelligent and autonomous. Comparing LangFlow and the OpenAI Agents SDK, both tools aim to simplify agent development, but they serve different purposes. LangFlow is best suited for 1. Rapid prototyping. 2. Visual experimentation. 3. Educational purposes. 4. Simple to moderately complex workflows. The OpenAI Agents SDK is better for 1. Production systems. 2. Complex logic and orchestration. 3. Fine-grained control. 4. Integration with larger applications. In many real-world scenarios, developers use both. 1. LangFlow for designing and testing ideas. 2. The OpenAI Agents SDK for implementing robust solutions. A hybrid approach. A powerful strategy is to combine visual and programmatic tools. You might start by designing an agent in LangFlow, experimenting with prompts and tool configurations. Once the design stabilizes, you translate the workflow into code using the OpenAI Agents SDK or another framework. This approach gives you the best of both worlds. 1. Speed during development. 2. Control in production. Best practices for building AI agents. Regardless of the tool you choose, several best practices apply. Keep tools simple and focused. Each tool should perform a single, well-defined task. Design clear instructions. Agents perform better when their goals and constraints are explicit. Monitor and evaluate. Always track how your agent behaves in real scenarios. Unexpected outputs are common and must be managed. Plan for failure. Agents can make mistakes. Implement fallbacks, add-ons, and safeguards. The future of agent development. The field of AI agents is evolving rapidly. Visual builders like LangFlow are becoming more powerful, while SDKs like OpenAI's are becoming more structured and easier to use. We are moving toward a future where 1. Non-developers can design agents visually. 2. Developers can refine them with code. 3. Systems can scale seamlessly from prototype to production. Understanding both paradigms is essential for anyone serious about building intelligent systems. Summary. In this chapter you learned 1. What AI agents are and how they work. 2. How LangFlow simplifies agent creation through a visual interface. 3. How the OpenAI Agents SDK enables precise, code-driven control. 4. When to use each tool and how to combine them effectively. Together, these tools represent two sides of the same coin: accessibility and control. Mastering both will allow you to build powerful, flexible, and production-ready AI agents. Chapter: Building Intelligent Systems with Llama Index. As AI agents become more powerful, one challenge continues to stand out: how to connect language models to real data. Large language models are impressive, but on their own, they lack access to your documents, databases, and knowledge sources. This is where Llama Index plays a crucial role. Llama Index is a framework designed to bridge the gap between language models and external data. It enables you to build systems that can search, retrieve, and reason over your own information, turning static data into intelligent, queryable knowledge. What is Llama Index? Llama Index is a data framework for building applications powered by large language models. Its primary purpose is to 1. Ingest data from multiple sources. 2. Structure and index that data. 3. Enable efficient retrieval. 4. Provide context to language models. In simple terms, Llama Index helps your AI understand your data. Without such a system, a language model operates only on its training data. With Llama Index, it can 1. Answer questions about your documents. 2. Analyze internal knowledge bases. 3. Work with PDFs, APIs, databases, and more. The core idea: retrieval augmented generation. At the heart of Llama Index is a concept known as retrieval augmented generation, RAG. Instead of asking a model to generate answers blindly, you 1. Retrieve relevant data. 2. Inject it into the prompt. 3. Let the model generate a grounded response. This dramatically improves A. Accuracy, B. Relevance, C. Trustworthiness. Llama Index provides the infrastructure to make this process efficient and scalable. Key components of Llama Index. To understand how Llama Index works, let's break it down into its main building blocks. Data connectors. Llama Index can pull data from many sources. 1. Local files, PDFs, text, CSV. 2. Cloud storage. 3. Databases. 4. APIs. This makes it highly flexible for real-world applications. Documents and nodes. Once data is ingested, it is split into smaller chunks called nodes. Why is this important? Language models have limited context windows. By breaking data into smaller pieces, Llama Index ensures 1. Efficient retrieval. 2. Better matching with queries. 3. Reduced noise in responses. Indexes. Indexes are the core structure that organizes your data. Different types of indexes exists, such as 1. Vector indexes. semantic similarity. 2. Tree indexes, hierarchical structure. 3. Keyword indexes, exact matching. These indexes allow fast and relevant retrieval of information. Retrievers. Retrievers are responsible for selecting the most relevant pieces of data for a given query. For example, 1. A vector retriever finds similar chunks. 2. A keyword retriever matches exact terms. Retrievers ensure that only useful context is passed to the language model. Query engine. The query engine ties everything together. It 1. Accepts a user query. 2. Uses a retriever to find relevant data. 3. Sends that data to a language model. 4. Returns a final answer. This creates a seamless experience where users can ask natural language questions about complex datasets. Example workflow. Let's walk through a simple example. Imagine you have a collection of technical PDFs. With Llama Index, 1. You load the documents. 2. The system splits them into nodes. 3. A vector index is created. 4. A user asks, what is Kubernetes autoscaling? 5. The system retrieves relevant chunks. 6. The language model generates a precise answer based on those chunks. This is the power of combining retrieval with generation. Llama Index and AI agents. Llama Index is not just for question answering, it plays a critical role in AI agents. Agents often need access to 1. Knowledge bases. 2. Documentation. 3. Historical data. Llama Index acts as the memory and knowledge layer for these agents. For example, 1. A customer support agent can search company documentation. 2. A DevOps agent can analyze logs and configs. 3. A research agent can read and summarize papers. In this sense, Llama Index complements frameworks like LangChain and LangGraph. Llama Index versus LangChain. It's common to compare Llama Index with LangChain, but they serve different roles. LangChain focuses on tools and workflows. Llama Index focuses on data and retrieval. A useful way to think about it: Llama Index equals data brain. LangChain equals action layer.